Welcome to our workshop session on manufacturing and mechanics of composites, organized and sponsored by Center for Railway Research, IIT Kharagpur. I am Nilanjan Chakladar, Associate Professor in the Department of Mechanical Engineering, IIT Kharagpur. Today I will be taking you on a tour to manufacturing of composites, followed by Professor Atul Jain in the field of micromechanics of composites and Professor Aghna Mukherjee in the field of mesomechanics of composites. High-speed rail is the future of transportation in India and abroad. Lighter the weight of the vehicle, more efficient is the fuel requirement. Hence, we need to move to a material which is lightweight and which can perform at par with the traditional steel. However, we should get the advantage of the lightweightedness of these advanced materials. As we know, there are plenty of researches going worldwide in laboratory scale, but they are now being transitioned to the industry scale through automated robotic fiber placements, robotic filament winding and other out-of-autoclave techniques. So there are ample opportunities in India to bring the lab scale composite manufacturing into industry scale. So join us in this particular workshop session and let us ride together into the journey to the world of composite materials. Thank you.
Hello everybody, I am Dr. Atul Jain. I am an associate professor at the Indian Institute of Technology, Kharagpur. My research and teaching interests are mechanics of composites. In particularly, I am interested in the micromechanics of composites, where we look at the constituent properties of the individual members of the composites, that is fiber and matrix. Okay, so think of composite like a house. The strength of a house depends on the quality of the brick and the cement that we use. Similarly, the strength of a component depends on how the fibers and the matrix are interacting or bearing the loads. Currently, the state of micromechanics is so advanced that we can a priori predict how a material or a component is going to behave when it is exposed to certain kind of load. So we don't need to worry about doing tests all the time. We could actually design something and the test should only be at the final. So this speeds up the complete design cycle without the need of expensive tests.
Hello everyone, my name is Dr. Aghna Mukherjee. I am an assistant professor in the Department of Mechanical Engineering, and in this course I'll be talking about mesomechanics of composites. So the mesoscale is where individual fibers organize themselves into bundles and weaves, and that's precisely where cracks are born under load. Miss this scale in your analysis and you will completely misjudge how long a structure will survive. So every insight from mesomechanics basically gives us an idea how strong a panel is, like whether it is better for crash and all, and whether the components will fail without warning. Ultimately, this research will lead to passengers reaching their destinations safely. And that is what drives the work.